In the first paragraph containing question number 11, 12 and 13, it is given that a particle of mass m is placed on top of a block of mass 3m having the shape of a circular cross-section of radius r as shown in figure. If all the surfaces are smooth, then answer the following questions. When particle reaches its lowermost position, then. So this is the graph of the paragraph. So in that case, suppose after time t, this particle reaches the bottommost position, then at that moment let's velocity is v1 with respect to ground and the velocity of mass 3m is v2 with respect to ground. So the relative velocity of this particle with respect to the center of the block can be written as v relative. So that is equal to v1 plus v2. Since the surfaces are smooth, so we can apply the principle of conservation of mechanical energy. So loss in potential energy is equal to gain in kinetic energy. So I can write mg into r is equal to half into mu. So mu is reduced mass of system, m into 3m by 4m into v relative square. So from here the value of v relative comes out to be 2 times under root 2gr by 3. So option A is correct and B is wrong. Now we have to find out the value of the normal reaction on the particle at this instant. So if I draw the free body diagram, n is acting in this direction, mg is acting in this direction. So we can write the equation with respect to the center of block, n minus mg is equal to m into v relative square by r. So if I substitute the data of v relative, then the value of n comes out to be 11 by 3 mg. So option D is also correct. So the correct answer for question number 11 are option A and D. Let's move to question number 12. In question number 12, we have to find out the path followed by the particle in this graph. So we have to find out what is the path followed by the particle with respect to ground frame. So in the frame of the center of block, the path is circular, but in the frame of the ground, we have to find out its mathematics. So this is the block, and at t equal to 0, this particle is at this position. Let at time t, the particle has come to this position and the block has moved in this direction by distance x. So this mass is 3m. Let I am considering as capital M, and the mass of this is m. So if the block is displaced in left direction by a distance x, then I can write m into x is equal to small m. If this angle is theta, this radius is r, then the displacement of small m in this direction is m into r into 1 minus cos theta into minus x. Since the external force is acting in the vertical direction only, so there is no displacement of the center of mass in the horizontal direction. So we can write this equation. So after solving this, I can write in this way: x into m plus small m divided by small m is equal to r minus r cos theta. Or I can write x into m plus m divided by small m minus r is equal to minus r cos theta. Similarly, if I write the equation in vertical direction, then the vertical displacement of the block can be written as r sin theta, that is equal to y. So if I square this equations and add these equations, then we will get the equation of ellipse in the ground frame. So the shape of the path followed by the particle is considered to be elliptical with respect to ground frame. So option A is correct and B is wrong. Now we have to find out what is the radius of curvature of this particle at the lowermost point of its path. So at the lowermost point of its path, we have already known that it is moving with a velocity v1 with respect to ground. So we can write Here we have find out the centripetal acceleration AC. So AC is equal to V relative square divided by R, and it is also equal to V1 square divided by radius of curvature at the lowermost position. So the radius of curvature at the lowermost position can be find out from here. Now we have to find out what is the value of V1 in terms of VR. So we can say that M into V1 is equal to capital M into V2, where capital M is 3M, and we also know that V1 plus V2 is equal to VR. So if I solve this, the value of V1 in terms of VR comes out to be capital M divided by capital M plus small m into VR. So if I substitute the value of capital M, that is 3M, then it comes out to be 3 by 4 of V relative. So if I substitute the value of V1 here, then VR square by R is equal to 9 by 16 VR square by rho. So the value of radius of curvature at the lowermost position comes out to be 9 by 16 of R. So option D is also correct. So the correct answer for question number 12 are option A and D. Let's move to question number 13. In question number 13, regarding the motion executed by the block. So the block is moving in the horizontal direction, so its motion is oscillatory in nature. So option A is correct and B is wrong. Now we have to find out what is the maximum displacement of the center of mass of the block. So the maximum displacement of the center of mass of the block can be found out in this way. This block moves in this direction by a distance x, then small m moves in this direction by m into r minus x. So m into r minus x plus 3m into x, their summation must be equal to 0, as the center of mass displacement in the horizontal direction is 0. So if I solve this, then 2x comes out to be minus r, or x comes out to be minus r by 2. So option C is also correct. So the correct answer for question number 13 are option A and C. Let's move to the second paragraph containing question number 14 and 15. So in the second paragraph containing question number 14 and 15, it is given that a block A of mass m is resting on a plank B of length L and mass 2m as shown in figure. Horizontal surface on which the plank is capped is smooth, whereas coefficient of friction between block A and plank is half. A ball of mass 2m is thrown with velocity v0 towards plank B and collision takes place at t equal to 0. If coefficient of restitution for the collision is half, then answer the following questions. In question number 14, velocity of plank just after collision is v1 and v2 dash is the final common velocity of A and B. Then we have to find out the validity of given options, and we have to assume that L is to be large. So let immediately after collision the velocity of the plank of mass 2m is v1 and let the velocity of this ball of mass 2m is v2. Since if I consider the plank and the ball as a system, then no external force act in the horizontal direction. So we can apply the principle of conservation of linear momentum in horizontal direction. So 2m into v0 is equal to 2m into v2 plus 2m into v1, or v0 is equal to v1 plus v2 is my first equation. If I apply the equation of Newton's law of collision, then I can write E, that is half, is equal to minus of v1 minus v2 divided by 0 minus v0. So it comes out to be v0 by 2 is equal to v1 minus v2. So this is my second equation. So if I solve this two equation, then the value of v1 comes out to be 3 by 4 of v0. So option C is correct and B is wrong. Now I have to find out what is the value of v2 dash. So v2 dash is the final common velocity of A and B. So after the collision, we can consider A and B as a system, as the friction force is internal force of the system between them. So I can write 2m into v1, that is 3 by 4 into V naught is equal to total mass of system, that is 3m into V final or V common. So from here the value of V final or V common comes out to be V naught by 2. So in the given options A and D, the value of V2 dash is something else and not V naught by 2. So option C is the only correct answer. In question number 15, for V naught is equal to 20 meter per second and L is equal to 15 meter, if T equal to T naught is the instant when A and B separate out, then at that instant we have to check the validity of given options. So if I draw the free body diagram, then this plank received impulse in this direction. So due to this, in order to oppose the motion, the friction will act in this direction, and on this block of mass m, the friction will act in this direction. So the value of the acceleration is in this direction is mu into g, and the acceleration of the plank in this direction is mu g by 2. Now if I see the motion of the plank in the frame of A, then the relative acceleration is 3 by 2 of mu g. Now I have to apply the equation of relative motion. So initial relative velocity of B with respect to A is 3 V naught by 4 into T. So U into T minus half into A relative, that is 3 by 2 into mu g into T square is equal to L. So if I substitute the data, V naught is given, the value of mu is half, then the value of T comes out to be 2 seconds. Now at this moment, if I find out what is the velocity of this block A, that is VA, and the velocity of block B, so VA is equal to 0 plus acceleration, that is mu g, so half into g into t, so it comes out to be 10 meter per second. And if I find out VB, so this is equal to initial velocity is 3 V naught by 4, so 3 by 4 V naught is 20 minus acceleration, that is retardation, so it is half into mu, that is half into g, that is 10 into t. So if I solve this, it comes out to be 10 meter per second. So at this moment, the velocity of block A and block B are same. So the relative velocity of B with respect to A is 0. So we can say that option D and option B is the correct answer, because at this instant when the length is 15 meter, then they will separate out at t is equal to 2 seconds. So option B and D is the correct answer. Let's move to question number 16.